When it comes to the future of enterprise storage solutions, virtualization integration is an essential trend that cannot be overlooked. In this space, QSM4 stands out as a powerful platform that seamlessly connects virtualized environments with storage architectures. It not only enhances resource utilization, but also simplifies management processes, enabling businesses to achieve greater efficiency and stability. Today, we will dive into how QSM4 leverages virtualization integration to deliver game-changing value. With the growing demand for flexible and scalable storage solutions, Proxmox emerges as a robust hypervisor designed to optimize virtualized environments. It provides enhanced performance, improved resource management, and greater compatibility with modern IT infrastructures. One powerful use case is the combination of Proxmox and QSM4, offering an efficient solution for businesses to manage virtualized workloads. Through this integration, you can set up Proxmox hosts and use QSM4 to establish an NFS share. This NFS share can then be mounted to a Proxmox cluster environment for deploying Linux or Windows virtual machines. This setup aims to demonstrate the application of virtual machines with redundancy features, providing insights into achieving high availability and efficient data management in virtualized infrastructures. We can see a simple and intuitive topology that uses 3 Proxmox hosts and an XN5116S to establish an NFS share. This NFS share can then be mounted to a Proxmox cluster environment for deploying Linux or Windows virtual machines. The setup is designed to demonstrate the application of virtual machines with redundancy features, providing insights into achieving high availability and efficient data management in a virtualized infrastructure. During the virtualization process, businesses often encounter numerous challenges. First, time consumption is a significant issue. With the increasing demand for high-speed data, setting up and managing equipment upgrades requires a considerable amount of time, impacting overall efficiency. Second, there are limitations with outdated hardware. In many cases, older devices cannot be fully phased out, which hinders overall hardware performance and becomes a barrier to further upgrades. Additionally, extra costs must be considered. To maintain data portability and implement a flexible device strategy, businesses need to invest additional resources in integrating existing and new devices, adding to the financial burden. Heavy server loading is another common challenge. Virtualized architectures or databases often generate a massive amount of I/O requests, making it difficult for storage devices to handle the load and ultimately affecting the performance of the host server. Lastly, there's the issue of unstable output. To address system latency and performance issues, equipment managers frequently need to manually adjust the resource allocation of storage devices to meet demands, which is often insufficient to fully resolve the problems. In this use case, we will explore how to set up and manage Proxmox VE in conjunction with QSM4 to establish an NFS share. This configuration ensures seamless integration between the Proxmox VE environment and QSM4 storage, offering a reliable and flexible solution for deploying virtual machines. The combination provides enhanced performance and scalability, enabling businesses to efficiently manage virtualized workloads while maintaining data security and accessibility. This setup serves as a practical example of leveraging Proxmox VE and QSM4 NFS for high availability and efficient data management in a virtualized infrastructure. In QSM4, create a pool and file volume, then create NFS share and add it into share host. Access the GUI of one of the Proxmox servers and navigate to the cluster page to create a cluster. Enter cluster name and choose cluster network. After creating the cluster, click on Join Information. Copy Join Information. Navigate to the GUI of another Proxmox server that wishes to join the cluster and click on Join Cluster. By pasting the join information and entering the password for the cluster node, you can successfully join the cluster. Repeat steps 5 and 6 on the Proxmox servers that have not yet joined the cluster. Once joined, the setup will appear as shown in the following image. Navigate to the storage page of the data center and create NFS. Enter the ID and fill in the storage IP in the server field, then select the NFS share you created in the export option. After the setup is complete, ensure that all nodes have NFS storage. Create a VM using NFS storage. After the VM is created, the HA state appears as none, indicating that the VM does not yet have HA functionalities enabled. Navigate to the HA group page in the data center and create a group. Then go to the HA page, add the VM, and select the group that was just created. At this point, you can see that the HA, high availability state, has changed to started. In this test section, we will demonstrate the processes of VM migration and VM failover. This stage is crucial to validate the seamless transition and resilience of virtual machines within our environment, ensuring they maintain functionality under various conditions. Before proceeding with VM migration or failover, you need to first unmount the installed ISO from the VM on the hardware page. Go to the VM console, click on Migrate, and select the node to which you want to transfer. After the migration is complete, verify that the VM's ownership has been transferred to the designated node. You can try shutting down the node that owns the VM to simulate a disaster scenario. You may notice that the VM does not automatically fail over when the owner node is shut down. At this point, you can adjust the priorities in the HA group by setting the priority of the failed node to the lowest and the node you want to transfer to as the highest. The VM will then be failed over to the node with the highest priority set. Confirm that the VM has successfully failed over to the node with the highest priority and is operating normally. In conclusion, this event effectively demonstrates the process of setting up a Proxmox high availability cluster using NFS Share, which includes the configuration and implementation of VM migration and failover tests. Provides a comprehensive tutorial for establishing a robust and resilient virtualized environment in QSM4, ensuring the continuity of service and data redundancy. We have also explored various storage solutions and their capabilities in supporting virtual machines, VMs, under different operational conditions.